Okay, guys, thanks for coming out today. I'm Wayne Carter. I'm from Couchbase, and I wanted to talk to you a little bit about making mobile applications that are always available and always responsive, regardless of whether or not you have a network connection. So, um, also during the session today, we're going to have a couple of people come up and join me. Chris Anderson from Couchbase will be we'll be showing you guys an HTML5 app that's pretty cool, and then Jon Udell from Microsoft is going to come up and talk about an experimental project they're working on, looking at what it would mean to make the web truly peer-to-peer, and they'll come up here in a minute. So, just starting with why we can't have mobile applications that are always available. So, most of the applications today that we write have a problem. The problem is that the data is all remote. So if your application has a connection to the internet, then great, your application works. If the network connection is fast, then great, your application can be fast. But if the network isn't there, then your application can't work. And if the network connection isn't fast, then your application is going to be slow. So it leaves us in a bad situation where apps just sometimes work. We can't really depend on them to work all the time. We also can't depend on them to be fast all the time. And it's just really a factor of our choices of where we store the data. So we're storing in the cloud today, and that's the way we access our data. So if we can't get to it, then the apps just don't work. So just looking a little bit more at the fundamental effects of data location strategies and what those effects, how they affect your application. Let me just step to the next slide, and this is a 5-column matrix that we stepped through just to kind of level set on a conversation to what these choices we make in our applications and how they affect the applications themselves. So in mobile applications and any other application, you have 3 different location strategies you can employ. So you can employ a data location strategy that stores your data remotely in the cloud, and it's only in the cloud, and that's what most of us do today. So if we have a network connection, great. If not, we just need to check back later. You can store all of your data locally. So this works for some mobile applications, not a ton, but it makes sense for some. And then the third is just a hybrid of the two. So storing your data both locally and remotely, and then having some mechanism to reconcile the differences between those two data stores. So those are your 3 choices. You choose one of them. Most of us choose the first one today. And those come with network requirements, which I kind of touched on earlier, which is that the remote-only strategy, it always requires a network connection. The local-only location, it never uses a connection, so it has no network requirement. And then the local and remote hybrid strategy only opportunistically uses the network to reconcile the differences between the stores. So we call that a sometimes connected requirement. So then we get into the actual effects on applications. So the first one we look at is availability. So does the app work or doesn't it? And with the remote-only strategy, because of the complete dependence on the network, the application can only sometimes be available. It can't be always available. And then with the local and hybrid strategies, because the data is local, your applications can be always available and aren't affected by the network. And the second aspect of application that we look at is responsiveness. So this is a bit of a nuance, but it's something that's very important. And this is just not does your application work, but how well does it work? How fast is it, right? So with the remote-only strategy, you actually are completely tied to the performance of the network. So if the network is fast, then great, your application is fast. But if the network is slow, then it's going to be slow. There's no way to get around that. And it actually results in a variable experience, which it's actually worse than just having an app that's always slow, because your users can't predict how the application is going to behave. So one interaction with it might be fast, the other one might be slow, just depending on the performance characteristics of the connection. And with the local and hybrid strategies, because the data is local, it's consistently fast. And then if the last column here actually just looks at the enabling technologies. So what technologies enable these strategies? And so the first one here is the remote-only strategy. It's enabled mean, there's other ways to enable this strategy, but the most common today is JSON over REST services. The local-only strategy is most commonly enabled using SQLite. It's a very popular embedded database and is available on all the major mobile platforms. And then the hybrid strategy is enabled through some synchronization mechanism. So if we look at that altogether, we see that if our goal is to make applications that always work and are always responsive, then we have two choices. We can have a local-only strategy, or we can have some hybrid strategy. Now, local only works for some applications, not a ton, but some. So we're really focused on enabling the majority of applications. And so the real solution here is to come up with some hybrid strategy that enables that. So looking at the solution, I've covered it, but I imagine you can guess is the local data plus some synchronization technology. And so the way we see this is that the next phase in mobile first is going to be a local first data strategy, so that the majority of your data access is going to be local, and the corner case is going to be to the cloud. And that's very different than what we're doing today. And so if we look at the common path towards that solution, it looks like this. Most of us are on step number 1 today. You'll then quickly move, if you want to get to some type of responsiveness or availability, you'll move into a read-only cache that's local. This happens a lot of your most popular apps. Look at Facebook, look at LinkedIn, many of the other ones. Smaller apps, this is tractable problem here. You can actually get to a read-only cache pretty relatively easily. It's not super easy, but you can get to it. The next step is usually a local write queue, where you cache up your changes locally, and then when you get a connection, you'll just blast it up to the cloud. There are some applications doing this today. Actually, Facebook just released a couple of days ago offline capabilities for their mobile application, where they're letting you write to your wall while you're offline, post pictures, status, this type of stuff. And I imagine, I don't know exactly how they did it, but I imagine they're probably on step number 3 here. And this works for some situations, especially when you have conflict-free data structures. You can usually get to a local write queue, but there are cases where it'll actually even fall short on that, and that's where you have data quality issues, where like in a lot of enterprise apps, when you're creating let's just use contact as an example. When I'm creating contacts, and I have a lot of people creating contacts in themselves are conflict-free as far as the creation of the contact, but it goes through a data quality process where how do you keep everyone from continually entering the same contact over and over? So you can actually, even in the situation of a local write queue with conflict-free data, you can run into a situation where it falls short, where you're not able to achieve what you need for your application. You'll then quickly move into, at number 3, you're going to be in a lot of pain. There's a lot of code associated with 2 and 3. There's actually a significant amount of code associated with number 1 also. A lot of our apps are significantly networking code. We imagine mobile apps as these super simple, small things, but they're actually distributed computing problems all packaged up into these cute little apps, right? And it's just not super easy. And so by number 3, you're in a lot of pain. You'll go into some version of number 4 where you're solving very app-specific sync code, and now you're locked in pretty tight into your code base. It's going to make you very heavy, make it very hard for you to move, and you're now committed to essentially becoming a data scientist at that point. And then number 5 is really the holy grail, which is multi-master synchronization, dealing with the actual fundamental aspects of synchronization, conflict resolution, distributed data, etc. And so that's actually where we see the answer. It's like we're not looking for interim solutions. It's just solve the whole problem and move on. So looking at that, the answer would be something that looks kind of like this, where you have a local database with synchronization mechanisms, a part of that database. Data can be stored in the cloud and then synchronized between the cloud and other devices, just as a feature of the data layer itself. So that means that you have applications that work while you're online, you have applications that work while you're offline, and so your users are just love your application because it just works and they can depend on it. So you got a nice thumbs up from your user base for that. and you can just focus on actually building your applications as opposed to dealing with all of the fundamental data problems and networking problems. So what does that mean? So it means you can build better apps. They just work. They're faster, and your users can depend on them. Second thing is, it's actually a lot less expensive to build. So you're not dealing with networking anymore. It's removed from the critical path. You deal with the app itself. You're writing applications like you're using a local store, and the reconciliation of these data stores is just, it's a problem for the data layer to figure out. And it's the least expensive types of apps to build are local apps, and so you actually get all of it for the expense of the cheapest types of apps. And the third thing that it enables is just applications that were impossible yesterday are now possible. So we hear this a ton where you just couldn't build the app because the cost of building that app is just way too expensive because you have to have Sync or some other reasons. So on that, I'll talk a little bit about a new product we have, which is called Couchbase Mobile. Couchbase is a big data company. We have a database that traditionally runs in the cloud. It's a huge scale out, high performance database, and we've announced yesterday that we were actually going to foray into the mobile space with a new product called Couchbase Mobile, with our goals being to solve this entire problem. So let me just step through that for a minute, and then we'll get you some really great demos using this technology. So Couchbase Mobile is made up of 3 components. It's Couchbase Lite, which is your embedded database on the device. You have a server component that we've added to our big database in the cloud. It's called Sync Gateway. It resolves all of your synchronization and security concerns. And then we have it backed by our super awesome Couchbase Server in the cloud. So just diving down in Couchbase Lite a little bit more. So it's fully featured. It's got all the features of our server database, plus a couple of other features associated with multi-master synchronization and conflict resolution. It's got the great, awesome, flexible JSON model that everybody has become used to for our server modeling. So you model the same way on Couchbase Lite as you would for the Couchbase Server. It's all in JSON. It's native, so we wrote this thing from the ground up, and that's really important. So we didn't take our server database and try to shove it onto a mobile device. Actually, we did try that many years ago, and we found out that just wasn't the right thing to do. And so what we did was we just reset, and we built these things from the ground up for the mobile platforms. And so we released native support for iOS, Android, portable Java, so this thing can run on anything that can run a J2EE compliant JVM, can run Couchbase Lite. We also have native support for OS X, and we're also announcing in beta a native built version of Couchbase Lite for .NET. And we wrote that with our partners Xamarin. If you're familiar with Xamarin, they're a big cross-platform mobile development platform, and those guys were awesome to work with to build this .NET version. We also run in a couple of other development platforms, PhoneGap being one of them, which might be of specific interest to you guys since this is HTML5. So it's lightweight, super lightweight. On iOS, it's like 500K to get this database in your app, and super secure. So it's SSL, transport, file system encryption on the device. There's a bunch of other security features built into Sync Gateway, which I'll talk about here in a second. So the second one here is Sync Gateway. So that's your server component, your outward-facing server component that deals with all your synchronization. It's an internet-facing component. So yes, it needs to deal with replication. It also has a bunch of security concerns that are built into this component. So it deals with authentication. We have pluggable authentication. Any type of authentication mechanism you want to use, you just plug it in, and we'll use that for authenticating your users and identifying them during all of the security concerns. It covers access control, data routing. So how do you split up? You have this huge data set in the cloud. How do you split it up and route some data to one user and some other data to another user? It has all of that built in, super easy to use. It's all of this is actually done using a scriptable component that's in JavaScript. So a little JavaScript snippet, and I'll show you here in a second what it looks like, but a little JavaScript snippet runs on any data mutation that comes through the Sync Gateway, so on any change. So create update, delete will come through this snippet, and you can decide what you want to do with it. Route it, secure it, give access to it, reject it if you don't want it, that type of thing. And then there's validation also. So just drilling down a little bit into these different aspects of Sync Gateway, let's just look at channels. So channels are, think of these as like lightweight publications in a pub-sub mechanism. So they're named slices of data. So you have this huge set of data. Now I want to slice it up into some named slices. So we have a little tool that you can use. It's scriptable in JavaScript like I was talking about. And you can create slices of data that you can then route to different users. So imagine this as a newsreader app, and I've sliced the data into one slice called sports. So all of the articles in the news that come in that have some relation to sports will get tagged with the sports channel and will now become part of the sports channel. And these two mobile users here, they're represented in the bottom left there, have subscribed to sports, saying that they're interested in sports. So they get all the sports channels. It's a really easy to use tool that's super powerful. So this one actually is another way that you could actually create a channel. So this channel is based on location, and the way this one was built was actually the devices themselves during a significant location change have posted their location to the server, and the server has then auto-subscribed them to this San Francisco channel just because they're in San Francisco. So if you live in San Francisco or you're visiting San Francisco, you'll then get all the data associated with San Francisco. And then channels are one to many, you can many to many actually, so they can be assigned as many channels as you want to as many users as you want, and then you can create specialized channels for whatever you need. So this one's an admin channel for your admin data needs. So super simple tool to just slice the data up and route it how you want. The Sinc function, I mentioned it's JavaScript, so this is what one looks like. The signature is all mutations come through here, so you get the old document and the new document, and you can decide what to do. So there's a couple of things in here. There's access control, so the filtering I've talked about, how you channel, that's the one there that says channel public. So it's saying if the document, so let's say the article is published, then make it available to everyone in the public channel. So in this case would be just everybody. But you could have a small set of people that you're deciding to route it to. You can also provide access to channels to users. So this one is hard-coded to Joe, but it could be any other way you want to get a user. It can be a single user, a list of users, or assigning data to a role. So if you see the next one there, the role admin, Joe is given the role admin, and now he'll be able to see any channels that are associated with that admin role. And then there's throw and these other types of validation tools that allow you to actually validate the data. Because this is internet facing, the data is just distrusted by default. So you can't guarantee that somebody's not going to inject data into your Sync gateway. It's outward facing, so it runs through this to determine that it's actually valid data. And if you don't like it, then throw it back out. It won't persist. And so it'll only be on the device that actually tried to put it in. And then the last thing is just Couchbase Server. So all of this is backed up by Couchbase Server. It's highly scalable, really easy to use, scale out, scale up. One of the fastest NoSQL databases on the market. So it's a great backend server. So at this point, I'm going to bring up Chris, who is going to show you his demo. It's an HTML5 demo. He's going to do it with Nate Vanderwilt. He's going to join us here remotely. So there we go. So I'm going to go ahead and throw your, yeah, okay.
So before I get started, just so that it's a little bit legible what's going on here, I'll describe the demo and let you look at that slide, and then I'll swap out my laptop and run it.
You want to just do it with you guys? You want me to?
Yeah, I'll hand you your laptop when I swap it. Okay. So typically the demos that we run will be more based around like a native app or even a phone gap container. But I wanted to do something special for HTML5. So we decided to take advantage of the fact that, essentially as a side effect of some of the other requirements we wanted to meet, so the ability to do peer-to-peer sync and the ability to make our data available to phone gap containers, well, the mobile component, Couchbase Lite, has an optional REST API, so it can act as a little bit of a web server. So what you'll see us doing is first Wayne and I are both going to connect to the web server that's running inside my phone, and it would be running in my real phone, but networks being what they are, it's running on my simulator. and we'll be interacting from 2 web browsers just on that local web server. And then Nate is, if the network cooperates and we're able to actually get an outbound connection, then we'll be bringing him into the channel so you can see that he's actually got his web browser pointed at his phone, right? And so then the 2 phones will merge their data sets via the cloud. And that's all happening, in a streaming real-time way. So the idea is that it gives us a whole bunch of flexibility. Operationally, the topologies you want to build for your app are essentially up to you. And it's also just kind of a fun app. I mean, there's been a lot of little peer-to-peer chats and lightweight chat apps are kind of a new category. So I thought I would build an example. So you'll see that in a second here, and you'll also see Nate joining us live via video, hopefully. And Nate actually gets the credit for writing most of this code. So yeah, let's see. My tethering has dropped twice in the last minute, but it keeps coming back. So I'm just going to hold out for the best. So. Getting pretty ready. So, all right. Let me see. I'll just, while I'm arranging my screens, the internet will start working again, right? That's how it always goes. Or, yeah. So, yeah, when that Wi-Fi comes back up, you'll be able to hopefully see and hear Nate joining us from Washington. He'd be here, except for there's a chance his baby will be born in the next couple of days. So, so congratulations to him. And yeah, good old hotspots. All right. So Nate, if you can hear me, we're back. We are back. And while we're waiting for Nate, I guess Wayne and I can show you a little bit of the basics. So in my other browser window, you see this is a, oh, excuse me. This web browser is pointed at my phone here, and if I allow the video to wake up, it should take my snapshot and say hello. There we go, and you can see it also pops up on the phone, and I can say, hey everyone in the HTML5 room, and that's recording a little bit of audio and video and synchronizing it via the phone to other devices. And hey everyone in the HTML5 room. So there it is playing off my phone. Here it is. Hey everyone in the HTML5 room. Playing out of the browser. And I don't know, Wayne, are you able to connect? So yeah, this there's this thing they do when they make hotspots for security. It's called client isolation, and I don't like it. But that's what we're suffering from right now is client isolation, and so we're using this hotspot instead. So yeah, cool. You're just flipping your Wi-Fi? Cool. Occasionally I have to bounce the phone's part too. This is great because Nate got to see everything streamed live video up until just a moment ago. So while we're waiting, I can show you, and this may actually be of more interest if you take our word for it that this is pretty cool when it works. You may actually be more interested in what it looks like to develop something like this. So this application again was built as a hack in the spirit of HTML5, so it's not the most beautifully factored code, but you can get a sense for what's going on. So it's as native of an Objective-C experience, and I know it's not super easy to read this, but we've pulled our library in via CocoaPods. If anyone uses CocoaPods, there's very little busy work there. And once the library is in, you just add a couple of headers in the right place, and bring in your database through normal native Objective-C code. Let me see if I can. There you go. That's better. And then we set up our indexes. So you can create an index with a name and inspect your data. And this is going to say, oh, let's sort, let's put everything from this room that has an image associated with it and make it available to a query. So, hey, that's a good sign. I think maybe I have internet. All right. Yeah, there's Nate. So say hi, Nate. He's up in Washington. Say hi, everybody.
Hi, everyone. Sorry I'm missing the conference.
And it looks like Wayne's also connected. Can you hear me, Wayne?
I can, Chris. I'm here with you in HTML5. Great to see you, Nate. I can, Chris. I'm here with you in HTML5.
I have my phone. What room are you guys in?
So just join the room HTML5, and all these messages should show up for you.
All right.
So, yeah, Nate will join the HTML5 room, and he should get some messages soon.
Hey everyone, HTML5 room. Can you hear me, Wayne?
I can, Chris. I'm here with you in HTML5. Great to see you.
All right. Hi, guys.
Do you want to say hey to him, guys? Go for it. Go for it. Hey.
And so you can imagine we have all kinds of fun with this app. You make little snippets, and I've got a whole database full of me just making silly noises. Oh, now Nate's got the message. Great. So yeah, thanks. I'm glad it worked. The network gods smiled upon us, and I guess the rest of the implementation that might be interesting to you is that we essentially have, and maybe it's not even, I won't try and show it to you, I'll just tell you. What we have is a little runtime script that's going to be very familiar to front-end developers. We use Grunt, or actually I think we use Gulp. I upgraded it, but we just have something that's watching the workspace, and when someone changes some code to change whatever, some browser logic, it packages that up as a JSON document with some HTML and JavaScript attachments, and saves that into the database running on the device. And then you have your browser connected to the phone that's sitting on the desk next to you, and you hit refresh, and you've got the new version of the code. And when it's time to deploy for the App Store, you can just take the binary assets that are created by your simulator as part of that process and package them up via Xcode and have it install on launch, so that you can have like some default data in your database on launch.
Is the sync function interesting? Do you have that?
The sync function is interesting in that it's 3 lines of code. It says if the document has a field called room, put the document in the channel called room dash that what was the value of that field, essentially. And then all we're doing, and it looks like we lost the internet, but you can see here that this particular phone has just a few rooms active. So we were playing around with some tests earlier, and there's a how-to room to
Welcome to Couch Talk.
give you a sense of how to use the application that's prepackaged with the app. But what happens is, this phone is interested in these 5 rooms. A different phone may be interested in a different set of rooms. And so every time you join a new room on your browser client, the phone notices and subscribes to another channel from the cloud. So you're only syncing the channels that are relevant to you down to your device, rather than having like a full flood into your phone. So, yeah, find me afterwards. I love taking people on code tours through, through what's going on here. We have an Android version as well, so we use the same browser assets for both platforms, and then there's just some slight differences in the native wrapper, but the application will run on any of our supported platforms via the Couchbase Lite REST API. So that's it for this demo, and I guess now we'll get to hear from Jon.
Ouch. Thank you. Thanks, guys. Okay, so we're working on this experiment called Thali. Thali is an Indian meal made up of a number of tasty dishes, and it's also our experiment to enable peer-to-peer communication on the web. It's a funny thing, of course. We kind of go around on this cycle. The web, or I should say the internet, originally was, of course, peer-to-peer. In fact, the early web was too. Things keep getting in the way of that, as we actually saw in the first demo with SSID client isolation and NATs and firewalls and in some sense actually cloud services, right? There are all kinds of things that get in the way of ultimately my device talking to your device and me talking to you directly. Well, why can't we do that, and why shouldn't we want to? Well, we do want to, actually. So that's the idea here. The Thali experiment is based on is in itself an open source project. On assignment right now to Microsoft Open Technologies. Thali is open source, but it's built on a set of open source foundations, principally Couchbase Lite, also PouchDB, which is a really quite awesome JavaScript implementation of the CouchDB protocol, and it's also an IndexedDB store. Mutual SSL authentication. So in our peer-to-peer system, you're never exchanging data insecurely. We always form a mutual authenticated secure connection to the peer that we're talking to. And in the wide area, and we don't have that working yet, or I would actually be able to do what I wanted to do here, we're going to be using Tor and Tor hidden services as a way to traverse NATs, firewalls, get around the kinds of bottlenecks that we saw here. And program Thali in a variety of ways, right? You can go, so Couchbase Lite, as Chris said, has an HTTP listener on top of that. We put SSL in there as well, so that we're talking securely to the database. And there's kind of three swim lanes here. There's sort of the .NET path. There's a Java path if you're trying to write native apps. At the moment, we're particularly interested, in fact, in the HTML5 path. And so that's what we're going to be looking at here. So the idea is HTML5. We think PouchDB is pretty interesting as a kind of universal client to really a family of databases that speak the CouchDB protocol, which include Couchbase Lite, CouchDB, and some others, and as well as PouchDB itself. And in fact, the app that we'll be looking at is not something I wrote. It's something that we just are using, somebody else built, and it's in fact a PouchDB and HTML5 app. So the idea here is that we have this thing called the Thali Device Hub, which is a singleton service that's living on your device. So it's on your phone, it's on your tablet, it's on your PC. And it embodies this the Couchbase Lite plus the listener on top of that. And then you're going to have multiple apps. And the idea here is that those apps are going to be externalizing their data into a common store. And particularly the idea is that that common store is one that you trust those apps to use on your behalf, because it's your data on your device, right? And you've authorized these apps to store that data, and you've authorized these apps to only communicate that data directly to trusted parties that you want to communicate with. So from that perspective, we think this is going to open up a lot of degrees of freedom in terms of what people are willing and able to do with their own personal information, because there are no intermediaries at this point. It's just you and whoever you want to talk to. So the identity model is, really not unlike good old PGP or SMIME, except that this is a peer-to-peer system. So, there are public keys. My identity is represented as a public key. Yours is represented as a public key. We exchange public keys, and that's how our peer systems agree to communicate. But there's no hierarchical CA, no certificate authority in the picture, right? This is self-signed certificates. We exchange keys, and then we authorize our mutual identities to access, subsets of the data that's in the common store. Conveniently, in the kind of wide area scenario, the Tor system also uses public keys, or really hashes of public keys, as identities. And so, this is going to enable us to find peer nodes across the network by their public key, rather than, let's say, by DNS, right? So it's a DNS bypass mechanism and a discovery and connection mechanism to, again, traverse NATs and firewalls. So the demo that we've got, actually, I said, it's not ours, right? It's a thing which could use a new name, because to German ears, I guess PPNet doesn't sound funny. It sounds a little funny to us. But anyway, this is a project that's funded by the European Union. There's a project that they have called the Future Internet Public-Private Partnership, actually. And they're pouring hundreds of euros into this thing and trying to develop a set of components. But what's behind this, right, is, this is Europe, right? And they actually care about privacy. And so they have this idea that they should be enabling a generation of internet applications that respect users' privacy and give users control over their own data. So to that end, they built a thing which is a little sort of Facebook-y like application. And it's, it's familiar stuff to you guys, right? It's Angular.js, it's PouchDB, and it's CouchDB. So, the scenario was they gave this app to a bunch of kids. They had their first public trial in Cologne, Germany, back in March. They gave the app to a bunch of kids. They were walking around, messaging one another and syncing from PouchDB on their devices up to an instance of CouchDB in the cloud, right? So we are almost not modifying this application at all. Basically, we're just pointing the PouchDB synchronization at a local embedded instance of Couchbase Lite rather than a CouchDB in the cloud, right? So this is, So this is kind of the setup for the demo. We have, on the one hand, we'll have an Android device, except it'll be an emulator because of the networking issues. And so there's this PPNet PouchDB application, an Android web view. We have some custom HTML request logic to talk to the hub, right? So Pouch will synchronize with Thali, the Couchbase Lite, and then this instance will also be syncing to that same instance. So this is the Android instance of Couchbase Lite and of Thali. Another way we could do it, because we run on the desktop using Java, so on Windows or Mac or Linux, it could go the other way, right? We could use the Java version of the Thali Device Hub, and in this case, the desktop app would be syncing to a local instance, and Android would be syncing to a remote instance. But really, as Chris said, the topologies that open up to you with this technology are a little bit bewildering. It gets, in a way, kind of hard to think about. Gee, there's so many different ways I could do it, right? What's the way we would like to do it? Ultimately, this is really the way we think this app ought to run. I don't think there should be any particular nominated instance of the source of truth, right? I just think that everybody should be running around with their own instance of a hub, right? And they should just do NY synchronization. When you think about social networking, you think about, well, Facebook is billions of users, therefore they have to be a massive cloud service. That's true. But that's true because in aggregate, they're supporting billions of users, right? But if you think about what really goes on in your life and the people that you communicate with, there's a thing called the Dunbar number that kind of caps your social interactions at, 200, right? We're walking around now with devices in our pockets that are perfectly capable of managing connections to 200 people, right? So, we like to think about flipping that paradigm and saying, why don't we just use that? We have that technology. We have the CPU, we have the bandwidth, we have the storage. on our devices, right? Let's keep the data close to ourselves, right? And communicate it directly to the people that we want to talk to, right? Like, why should it go through the NSAs and, you know, other people's purviews? So, so that's the pitch. Hang on a second. Let me wake up the emulator. Let me try to find my mouse in the emulator. Right. So, I mean, this is kind of your classic sync demo, right? You type it here and it shows up there. You know, but just to be clear about it, I should probably move these around so that they correspond to what was on the screen. It doesn't matter. So on the left is a Chrome browser. Chrome browser is this ppnet application that we got from Pixelpark, just lightly modified to be using sync to the Android-based instance of Couchbase Lite. On the right, there's two pieces. There's two APKs running, right? There's the Thali device hub running in the background as a service, which is Couchbase Lite and the listener, right? And then there's the same HTML5 client application, again using PouchDB. In this case, it's syncing to its own local instance of PouchDB, of Couchbase Lite, right? So it might take a second to wake up, but this is so on the left. This is Yaron Goland, who's the guy that actually is building this thing. And he might say, "Are you on stage?" And I wait for things to heat up, and yay, yes. So you get the idea. So not too exciting, but it shouldn't be, right? I mean, as Wayne was saying, right? You know, we want to take the magic out of this local remote hybridization and let people just do what they want to do. Just write the software, just enable people to do the things that they want to do with the people that they want to do them with. And we think that that ought to happen in a way, again, that puts people in control of their data, keeps the data as close to them and their devices as they want it to be, makes sure it only goes to the people that they want it to go to on terms that they authorize, and make it easy. There you go. Thanks.